Prince here.
Listen to that computer.
Prince might not present. Since he only was told to present like 2 days ago. So.
Okay. Onion gonna come? Should I wait a minute or two? We usually don't start right at 11.
Yeah.
Give it a few minutes. But anyway, so I tried. I've been trying to study Japanese a little bit lately, and then
How's it going?
went to
Good. How's your work going?
I was just on a plane and I was trying to watch a movie.
Right.
Especially because people always tell me, oh, they learn English by watching movies. Like one person was very clear. They said they first watched movies.
Just tonight. What are you doing here? Wow. Dedication.
I can't remember the name of the language. Let's say it was Chinese.
Right. Any excuse now?
I watched English language movies with the Chinese subtitles, and then I watched them again, but with the English subtitles, and then I watched them with the same movie over and over again. That's a really good way to do it. Anyway, so I tried listening to the Japanese, watching the Japanese movie, and I'm like, this has almost no relationship to anything I've learned before. Every single word you're saying, all of the subject matter is completely different, right? Because it was all just mean to each other and stuff. And they never teach you that. Can you imagine having a class on how to insult people? That'd be really fun.
Yeah, I mean the nature of cursing, I think, is really interesting too. But I'm just curious, how many languages do you speak? Or do you
natively one English, but I've dabbled. So usually if I'm on a trip somewhere, I listen to the words and I can get up to reasonably good speed to get around.
Not everything works.
But if I don't keep it up, I've done that for German, Italian, Chinese, Thai, Swedish, Japanese.
pretty impressive.
Yeah, but I can, I haven't done Mandarin in a few years. So I remember, I think,
getting good at
Do you want to do something like that?
something like that. That's I can't really do much more than that.
I feel like Chinese is as far as different as you can get from.
Well, in some ways it's not. At least it's the subject object.
Well, I would say that in Chinese we don't usually put the you don't put the time or place as very
Chinese is also very similar to English in that they have some morphology. Change a word to indicate tense.
Like a gender of an object.
Gender or number.
Right.
So you do a little bit in English, right?
Yeah.
That's kind of really.
Hi everyone, let's get started. So today, Denis, who is a summer intern here advised by John, will be giving a talk on translating idioms without destroying their meaning. So let's give it up for
Hello, and thank you very much for taking the time to attend my talk. As mentioned, I'm a summer intern here, advised by John May, and I'm going to talk about one of the projects I've worked on during my internship here at ISI, which is essentially centered on the challenging task of translating idiomatic expressions. Just a heads up, this is still very much a work in progress, and I will mostly be talking about corpus construction. The whole modeling aspect is still forthcoming, but should come together soon, hopefully. So I will first kind of start by providing some motivation on why idioms matter within the context of machine translation and why they're so challenging. Also talk about some background on work that has been done already on handling idioms both within MT and also in other NLP tasks. The core of the talk will, however, be on the idiom corpus, which is a new corpus I've constructed over the last couple of months. Specifically, what resources were used for it, how it was constructed, what are its advantages, and what are its shortcomings. I will follow that up by presenting some preliminary experiments we've ran to essentially ascertain that idiom translation still poses a veritable problem even for state-of-the-art machine translation models. And I will close the presentation by kind of giving an overview of the remaining work which still has to be done to make this project a valuable contribution to the field, hopefully. Why idioms? Why do idioms matter? So it has been shown in previous work on NMT that neural machine translation models do struggle quite a lot with non-literal translation, i.e., for instance, multi-word expressions there whose meaning is not essentially a combination of the meaning of its constituent terms. And idioms are a prime example of this type of linguistic event, as they do not follow principle of compositionality. For instance, if you have the idiom spill the beans, the meaning of this idiom itself has nothing to do with beans. Like spill the beans means to like mention something you shouldn't have mentioned, like say a secret. So nothing, no beans whatsoever. And such events are very difficult for neural translation models, which are strictly data-driven and mostly learn from co-occurrence of words. Another kind of big issue with idioms is that they are very low-frequency linguistic events. At least they are significantly less frequent than compositionally interpretable phrases. So the models are expected to develop a bias towards compositionally interpretable semantics rather than the alternative that the idioms represent. With this in mind, it's not surprising that kind of the main failure case of idiom translation are cases where neural translation models translate idioms literally, so essentially mostly word by word, and in doing so they destroy the intended meaning of the source side idiom. One caveat about this is that humans also sometimes use phrases which have an idiomatic meaning in the literal sense. For instance, if you have the sentence, "He spilled the beans all over the table," here the beans actually mean the beans. So you kind of have to know when to translate an idiomatic phrase as an idiom or when to translate it literally. And this is very tricky. So previously, there has been some work on handling idioms, both in NMT and outside of it, but largely it remains somewhat an under-researched area of machine translation specifically, presumably because of its challenging aspects. And most of the studies I'm familiar with regards to neural machine translation of idioms focus on performance evaluation. So they usually use small, sometimes hand-curated challenge data sets containing idiomatic sentences to measure how well or how badly neural models do on translating idioms. The largest of such sets, to my knowledge, covers about 130 idioms and consists of roughly 2,000 parallel sentence pairs, so it's still pretty small. And such sets also usually limit themselves to only a few translation directions, so the coverage is very limited. As a side note, idioms also have been found to be quite challenging for other NLP tasks. For instance, in sentiment analysis, the presence of an idiom can cause the model to output the incorrect sentiment label. So having a resource which has plenty of annotated idiomatic sentences can be useful outside of NMT as well. But yeah, overall, the area is still kind of somewhat neglected in NMT, and I hope it will receive more attention in the future. So since the larger overarching project, goal of this project is to improve neural machine translation.
What do you mean by pure translation direction?
So for instance, they usually look at like English to German alone in isolation, not like also English to Chinese or German to French. So it's usually limited to few language pairs and only a few language directions.
Thank you.
So since the overarching goal of this project is to improve machine translation of idioms, the first kind of intuitive step is to create a resource which can be used for this purpose, as there is no such resource at this time. And we have attempted to do so by creating the idiom corpus. Idiom here stands for idioms with definitions for improved on-point machine translation. Just ignore the translation bit, it doesn't fit into the acronym. But what essentially idiom is meant to represent, it should be a wide coverage multilingual corpus of parallel aligned sentence pairs where each source sentence contains an idiomatic expression, and the idioms contained in the source sentences are also linked to their monolingual definitions, which are not idiomatic. So you would have like a sentence, he was forced to spill the beans about the secret meeting in Moscow. And then you would have the idiom spill the beans in the sentence, and there would be a symbolic link to the definition of spill the beans as like say a secret out loud or something like that. So it's a kind of a parallel corpus with extra annotation involved. And kind of one compelling point about this corpus is it is built automatically from publicly accessible, massively multilingual resources, which are mostly curated by humans, so they have reasonably high quality. Currently, this corpus exists only for English, German, but with the tools that we've developed, it should be easy to extend the coverage to other language pairs, and I plan to do similar corpora for English, Russian, English, Chinese, at least in the foreseeable future. So what applications can this corpus have in the future? It can serve, for instance, as a very comprehensive challenge data set, as done in the previous work. Given its substantial size, it can also be seen as a fine-tuning corpus, perhaps, although this is problematic in some ways that I will touch upon later. But it can also be seen as kind of the first parallel corpus for the idiom translation by elaboration task, where instead of translating the idiom directly, you first transcribe it as its definition and then translate the sentence while also considering the idiom definition. So you provide an auxiliary context for the translation, which would otherwise be very difficult. So as for the resources that we used in the corpus construction, we obtained the idioms and the definitions from Dictionary, which is a publicly maintained open dictionary. From there, we got the idioms themselves, the definitions, sometimes synonyms of idioms, and sometimes translations of idioms. But the synonyms and translations occur with high irregularity, so not all of idioms have them. So we kind of ignore them mostly for the construction of the corpus. We extracted parallel pairs containing idioms from the combination of the TED 2013 and Open Subtitles 2014 corpora. The TED corpus contains transcripts of TED talks, while Open Subtitles corpus consists of subtitles, as the name implies. We chose those corpora because our intuition is that those corpora fall under the colloquial language domain and are as such more likely to contain idiomatic expressions, which tend to be more colloquial in nature. And combined, those corpora amount to roughly 19 million parallel sentence pairs. To refine our extracted corpus, we rely on word-level dictionaries, parallel dictionaries. And here too, we rely on publicly available resources. So we use the Facebook News dictionaries. And we also scraped, we also scraped the DictCC dictionary website, which is again a publicly maintained parallel dictionary which covers several language pairs. Both of those dictionaries capture polysemy and also contain inflected forms, which is good as this increases the coverage of our work. We were considering using the Muse dictionaries alone, but this has been problematic as those dictionaries end up being quite noisy and also some weird blind spots where they don't have entries for relatively high frequency terms in them, but they are automatically derived and have a wider coverage than DictCC, so we also include them. So I will kind of go into more detail how exactly the individual steps were done. So these idiom scraping is pretty straightforward. We first parse the category English idiom page in the English dictionary, follow the links from there to individual idiom pages, and parse those pages to get the part of speech tag associated with an idiom, the idiom definition, and also the idiom synonyms and translations where those were available. We refined this idiom database by further replacing definitions which refer to other idioms, such as idiom A is synonym of idiom B, by simply linking the definition of the referred to idiom to the referring idiom. And we also had to do some extensive cleanup of the extracted definitions, translation synonyms, because of the inherently noisy nature of like community-driven resources, like removing annotations and parentheticals in general. For the sentence mining part, we considered two strategies, which both are fairly basic. The first one, the source token match, and the other is source lemma match. For the source token match, we essentially check if all tokens comprising an idiom occur in the candidate source sentence. If that is the case, we extract the sentence. For the lemma match strategy, we first lemmatize both the idiom and the source sentence, and then look for matches. We found the lemma match strategy to be a bit too permissive. For instance, if you try to find matches for an idiomatic expression containing Downing Street, the script extracts sentences like she walked down the street, because Downing and down apparently have the same lemma, according to Spacey, which I disagree with. But yeah, so we kind of stuck with the token match strategy for the most part. We also allowed for discontinuous and rearranged idiom matching, so we allow non-idiomatic tokens to intervene between the individual tokens comprising the idiom, and we also allow idioms to be matched out of the canonical order to allow to essentially account for reordering effects. And if the sentence is extracted, we also construct an in and out of idiom tag sequence, where each source sentence word is either given the in or out tag, depending on whether it is part of an idiom or not part of an idiom. So following the token mesh strategy with at most one token intervening between the individual idiom tokens and with reordering allowed, we extract 4.6 million parallel sentences for 6.1 thousand idioms, which is quite substantial, but not all of those extracted sentences are actually useful, because many of them include literal uses of idioms, which we want to avoid. Some of them include incorrect idiom translations, which we also don't want to have, and some of them are just misaligned sentence pairs because open subtitles is not very well aligned in that regard. So to filter out those undesirable sentences, we'll consider several filtering strategies. The first one is the lemma overlap filtering, where we first identify the translations of the source idioms by computing alignments between the source and target sentences and looking at which target words are aligned with the source side idiom tokens. We also generate synthetic literal translations of the source side idioms from bilingual dictionaries, which I mentioned before. We then lemmatize both the mined idiom translations and the synthesized literal idiom translations and look at the overlap between the two. If we find some degree of overlap that we can predefine between the two definitions, we reject those sentences under the assumption that those sentences contain a literal translation of the idiom, which we don't want. The other strategy is semantic similarity filtering, which is similar to the lemma overlap, but instead of the overlap being the rejection criterion, here the rejection criterion would be the cosine similarity between the pooled embeddings of both mined and literal translations. So if the similarity is above a certain threshold, we reject the sentence. The third strategy is fairly different. So here the competence-based filtering. First, we train an NMT model on the rejected sentences, which were not included in the initial idiom corpus during the mining process, and then use this model to essentially translate our candidate idiom sentences, based on the assumption that this translation model should not be able to handle idioms particularly well. And if we reject sentences, so based on the assumption, we only keep sentences that the model has difficulty with, as this would be a signal that the sentence pair indeed has a figurative translation of the source side idiom. To further prune like the badly aligned sentences, we also reject sentence pairs which have where the source and target tokens, which are not part of the idiomatic expressions, are not fully aligned or not aligned to some degree, as incomplete alignment can be seen as a signal for bad sentence alignment in general. Following this filtering process, where we use lemma overlap without any overlap between the literal and mined translations allowed at all, and requiring the out-of-idiom alignment coverage to be at least 50%, we end up with a corpus of 1.6 million sentence pairs covering 5.4 thousand idioms, which is still quite substantial. Unfortunately, the corpus is not perfect in its form, despite the fairly aggressive filtering strategy. So some of the problematic sentences which are still included are sentence pairs where the translations are arguably correct, but simply omit the idiom instead of translating it. So the example here would be like sugar and spice, you know what, forget it. This is the source sentence, and the target German translation only translates the you know what part. So it's not per se inaccurate, but it kind of does not cover the phenomenon that we want to pay attention to. Some interesting other failure cases of the mining procedure are false positives. So a sentence like "I was showing her how to boot up in safe mode" was matched to the idiom to boot, like he was smart and handsome to boot. It's like a emphasis marker, essentially. So this clearly has a completely different meaning, and the German translation also, the accurate translation of the non-idiomatic term. But most of these samples are actually ones that we want. So, and those fall into roughly into three categories. The first category is where there is matching target idiom for the source idiom. So for the English sentence, a blessing in disguise, perhaps, the translation is vielleicht ist das noch Glück im Unglück. Glück im Unglück is a German idiom which has semantic equivalence with the German idiom, to my knowledge. So this is quite a fortuitous match.
What's the literal translation?
Luck within lack of luck. So yeah, you're unlucky, but you're still lucky. And the second category is where there exists a matching target idiom, but the translation provided by the parallel sentence is not idiomatic itself. So for the idiom dime a dozen, the translation is gibt's viele, which is just a non-idiomatic German phrase, which means there's a lot of that. So it's kind of a transcription of the idiom followed by the translation of the transcription. And the third case is where there exists no appropriate target idiom, to my knowledge. So the translation again has a non-idiomatic string expressing the same semantic content as the idiom. So yeah, I think this shows that it is important to not just try to find matching idioms when translating idioms, like on the target side, but to actually strive to translate the semantic content expressed by the idiom, even though the output might not be as idiomatic. If we look at the distribution of sentence pairs matched per idiom, we can see that it is fairly skewed. So most idioms tend to have less than 1,000 parallel sentences matched to them, with the tail upwards being quite long. So it indicates that it might be useful to consider other resources for idiom mining to improve the coverage, and also shows that the low frequency of idiomatic expressions is a problem that is not trivial to solve. And additionally, the idioms for which many matches exist may be very trivial, like not trivialized, but conventionalized, and as such may also not pose a big challenge to neural translation models due to their frequency in the data. So it's questionable how useful it is to include idioms with a high number of matches into the final corpus. So to evaluate whether the corpus we created is actually doing what it's supposed to be doing, so being a challenging benchmark for translation models in the sense that it captures idiomatic expressions, we evaluated the current de facto state-of-the-art translation model for English-German, the winning submission of the WMT19 task, which is a transformer by Facebook Research, trained on a large amount of mostly news domain data, but also on Paracroll, which is a mixed domain corpus. So even though the model is somewhat out of domain for the data that we have in our idiom corpus, there should still be some overlap due to the presence of Paracroll. And for the tests, we sample 5 test sets from our idiom corpus and also 5 test sets from the rejected part of the TED plus Open Subtitles corpora. We compare the average bleu for both categories of test sets to see whether the translation performance deteriorates on the set containing a high amount of idiomatic phrases. And we also try to estimate the frequency with which the model produces literal translations for the source idioms using a modified version of the blacklist metric, which is essentially the same as first generating synthetic translations, synthetic literal translations of the source idioms, and then seeing if the model output contains any of the tokens the literal translations contain. It's quite a conservative metric, which overstates the degree to which the model has difficulty with the idioms, I think, and refining it in the future will be a useful kind of contribution, but it provides a useful orientation point nonetheless. So the results are as follows. As you can see, there is quite a substantial drop in bleu for the idiom samples. I mean, 8 points for high-performing transformer models is not insignificant. And according to our blacklist measure, the model tends to produce at least partially literal translations in more than 60% of the cases, which is not a great result for the state of the machine translation with regard to the translation of idiomatic phrases, and also shows that future work is required. So here are some failure cases from the model translations. The first example kind of shows a very fancy idiom, quite complex, both semantically and on the surface level. So Baloo, birds of a feather should flock together, and the model pretty much translates it word by word, which does not make any sense in German. So it's kind of, none of the meaning is preserved and is essentially gibberish. For the second example, the idiom is much more conventionalized. So take a number, I think is a very high frequency idiom. Nonetheless, the translation, again, is literal and at best questionable in German. You might get away with it, like with some people, but I don't know. And the third example shows an interesting failure case where the model just resorts to copying the English idioms instead of even trying to translate them, which is not great either. I mean, it's a good backup strategy for some phenomena like named entities, but for idioms it doesn't quite work. I don't know what a grand poop is in English. I certainly don't know what it is in German. So it's not very... So given that we have identified those issues or reasserted them, and also have this comprehensive corpus now at our disposal, so what remains to be done? So the next step would be to leverage the corpus that we have. In particular, I think the idiom definitions are an interesting aspect to incorporate into the neural machine translation model. With regard to the corpus itself, it might be good to extend it with more parallel data, such as the WMT and paracrow data, which is also highly multilingual and covers a lot of different domains by paracrow. And also it would be good to reduce the occurrence of false positives by combining several of the proposed filtering strategies. As for the development of methods for incorporating idiom definitions into machine translation for improving the idiom translation quality, there are several approaches we would like to consider. A very naive one would be to replace idioms with their definitions and then hope that the model manages to produce useful translations from that. This, however, is, I think, not going to be very effective because idiom definitions tend to be quite long, and the transformer by itself struggles with long sequences already. It might be it might be worth considering to use hierarchical encoders where we separately encode the definition and the source sentence and then combine them in some way to provide the model with an additional context, similar to the approaches used in document-level translation. It might also be a useful strategy to discover appropriate target idioms by pivoting through embeddings of the definitions in a cross-lingual space. So essentially, you try to find idioms which are the definitions of which are close to the source definition in some embedding space, and then use this closest neighbor target idiom in the generated translation. One approach would also be to use generative pointer networks in the decoder to essentially allow the model to look up the useful bits of the definition while generating the translation. And one last approach that I would like to consider is maybe to first translate the part of the source sentence which does not include the idiom, maybe replacing the idiom by a placeholder token, and then use a target size conditional language model, which is both given access to the encoded source sentence representation and the encoded translation of the source idiom's definition to fill in the gap which was left behind by not translating the source idiom. So it would be kind of, I mean, neural models seem to be quite well at gap filling, so I think it might be a worthwhile approach to consider. So yeah, we intend to run some of those experiments at least in the following months and see which of the approaches are most promising and whether idiom definitions can be a useful signal for idiom translation. Yes, I think that's pretty much it. Here are some links where there might be information regarding the corpus and the models in the near future. And thank you for your attention. If you have any questions, do please ask. Yes.
One thing that I kept thinking about is that idioms are constantly being made from like popular culture references and just, I don't know, whatever current events happen. Do you have any like sort of strategies for dealing with unseen idioms?
Not with unseen per se. I mean, I think there's a difference between like slang and idioms. Idioms have to be somewhat conventionalized.
Okay.
And one kind of strategy, I guess, if you deal with the productivity of idioms is by just rescraping dictionary. Dictionary does get expanded by its users like repeatedly. So it's a resource that we chose with this reason in mind in part.
Yeah.
So it's like a living, growing resource. But it would be good to actually have some method to automatically, I mean, there are methods for automatically detecting non-compositional phrases in natural language strings, which rely on constituency parsers, for instance. But this again introduces a reliance on a resource which might not be available and might not be of high quality. It's difficult. Yes.
For the final data set you have, do you have any systematic quantitative way to evaluate the quality of the data set?
No, if that was an option, I would be able to produce a much better data set. So if I could identify which sentences aren't great, it would be easy to filter them out.
Okay, but another question is, can you at least provide, even if you cannot automatically filter out things, can you at least provide some, maybe you can do a sample precision by manually look at them?
I could do that.
Because it's, I mean, I feel it would be nice to at least get an estimation of how good that data set is.
No, I definitely agree. I mean, for the languages we consider to have the corpus for, at least for English and German, English to Russian, I would be able to provide this sample precision measure myself. But one kind of hope is that by employing those filtering and extraction strategies, we already guarantee some level of quality, even though it is not as high as we would hopefully have in the end. So I agree that there should be some more principled evaluation of the corpus quality.
Yeah, I mean, even if you cannot guarantee 100% of the accuracy, but just by provide the estimation of how good it is, it will be already be a useful resource or information that when people use it or whatever they will.
And I did look, I did have a cursory examination just by sampling entries from the data set. And my impression is that the good samples outweigh the bad ones by quite a margin, which is encouraging, but it is, again, not very principled. So having a proper breakdown is one of the things which will be done in the future. Thank you. Yes.
This is really great. I think the resource is going to be super useful. About your blue score, kind of about the empirical result you showed, I wonder, it seems like kind of big difference for just to ascribe to idioms. So I wonder if you've worried about some confounding factors. So one thing to check would just be sentence lengths. If the idiom samples happen to be really long sentences, those are just going to naturally be hard to translate. Probably that's okay.
They actually tend to be very short.
Yeah, okay, then that's great. What about domain effects? So maybe these idiom samples come from a thing that's more of a mismatch to the training data than the rejected. In that case, you describe it more to a domain thing. And there might be a number of possible confounding factors.
Yes, the domain effect is definitely a concern. In the interest of time, I wasn't able to fine-tune the translation model on the in-domain data, but for the final evaluation, that would definitely be something that has to be done. Thank you.
Blacklist?
Blacklist is essentially a metric for evaluating the prevalence of literal translation of idioms. It's essentially like the original authors of the paper constructed a manual blacklist of literal translations of idiom tokens. So if you have the idiom spill the beans, the blacklist would include the translation of spill beans. And they only did it for like 50 idioms, so it was possible to do it manually. I couldn't do it manually, so I essentially leveraged the synthetic dictionary, the bilingual dictionaries. So my blacklists are much fuzzier and kind of less clean. So this number should be taken with a grain of salt.
So is idiom translation problem for just NMT systems, or do SMTs also suffer a similar problem?
That is a good question. I cannot say with certainty if this is the case. Maybe Kevin might be able to.
Assume the systems which extract rules might be able to, in a special case, phrases have idioms.
My guess is there isn't really good consistent parallel data, even if you had, I mean, you're looking at a case where you don't really have instances of these much in training. I mean, we do have, but like actually, I was wondering, you had one example where there was where like the idiom, it was a very frequent idiom, right? I can't remember what it was. Take a number. And actually, I was wondering, like, if you actually look through all the instances of take a number, I wonder if the variability of its translation would be greater than your average phrase.
Yeah, no, this is one problem of idioms that I did not mention, is that they seem to have much wider mappings as opposed to other phrases.
And so with that in mind, I think even an SMT system would be more likely to try to, use shorter phrases because it's going to have more reliable, right? If you have take a number with 50 different things once versus like a number, you've seen number in number or whatever. Is it all number?
It's just, yeah.
Okay. Anyway, you've seen reliable translations of the content words over and over again. You might be.
Yes.
So people often say that some things are just not translatable, and we kind of took, in the computational linguistics, we used to listen to the people who said that, and then at some point we got all this parallel data, and we started saying, what do you mean some things are not translatable? I mean, we pay translators, and they translate everything, and we can actually observe what they do, and everything's translatable in some way. So I guess it'd be interesting then to think about what people do, and you had some examples. If you could do a bigger study of are people faced with idioms that they've never seen before and have to creatively come up with something, or are they just basically pulling out these translations from their memory, or are doing kind of a two monolingual corpora in their mind, and they kind of have to, they've never seen them together, but they have to match them. And
but interesting. I'm not sure if there is there has to be some literature and translation studies on idiom and
Well,
that's useful, maybe.
Well, I have a half answer. When it comes to like American Sign Language interpreting, I think you'll find that unfortunately there's like no data, but at least in the literature, there's a lot of interesting strategies on how to interpret phrases, because sign language really doesn't have idioms at all. Yeah.
Cool. I guess one more follow-up. So with Chinese, this should be an interesting project, because you can just pull these 4-character Chinese idioms. There's just huge lists of them, and you can just go directly. You don't have to do all this matching stuff.
Yeah.
Just do a literal match. And then most of the time, I try to figure out what those mean. That someone will tell me, send me to a Wikipedia page, and there's a giant article on something that happened during the Warring States period. I literally have to read all that just to understand these 4 characters. And
like Jalad and what is it? Darmok and Jalad and Tiagrat, do you know what I'm talking about?
Okay, so it's something similar. But so then it becomes like, are these things really translatable or not? But then it might be interesting to look and see what human translators do with those in a large corpus, because even they do deal with it, and sometimes they will give a little explanation.
Yeah.
Sometimes they'll try to get something loosely related in English, but that should be a super clear sort of data set.
Hopefully. I mean, like the practice of adding a footnote to the idiom is kind of a wrench in my works or whatever. So it's like a very unfortunate thing computationally speaking, but it's a very prevalent practice, it seems, for handling idioms.
Yeah, I think outputs of translation systems should have footnotes and should send you to Wikipedia pages. That'd be cool.
Yes.
I wonder, you've spent more time staring at these than I have. I wonder how much meaning can be recovered from the idiom itself. Like, instead of assuming, instead of assuming that the idiom and the translation have like very little direct meaning. Does that make sense?
Yeah.
Instead of assuming that, can you, like, for example, with spill the beans, like beans is almost like a symbolic sort of thing, and spill is also like, it's just like an interesting connotation of spill, and
I mean, we have like an external ontology that you can leverage, which provides a sufficient degree of world knowledge to the model, but it's like itself unsolved problem, I think, at this point.
Yeah.
But it would be good. I mean, I think we try to connect this problem to the problem of common sense reasoning, because you kind of rely on external knowledge for translating idioms like cultural knowledge, cultural connotations.
Yeah.
So, unfortunately, as far as I know, there is no resource that can be easily leveraged for that. So, of all the approaches that I have considered, at least, this seems to be the most manageable one.
Yeah. Because when I think about how humans, like, if I've never like encountered an idiom before that you're using, and I'm like trying to understand the meaning of it, I think that's how a human would do it. So
Yeah.
sort of like, okay, I don't know, just think about the different possible like symbols that
No, definitely.
I could have stood for.
I hate to interrupt, but we have other talks. We should probably.
Thank you very much.